This cake is to be dipped in a very thin covering of chocolate. Find the total surface area of chocolate needed. Now clearly we're going to need to cover this circle here, and there's also a circle at the bottom that we need to cover. But the curved surface is more of a problem for us because it's not just the curved surface of a cone. But consider the following. Imagine instead of having this frustum or part of a cone, that we had the whole thing. And it's the bottom part that we've actually got. This is 12, this is 6, this is 10. Now, because it goes 12, 6 and then down to 0, I'm going to say that this length here is 10, just from here to here. Now let's look at how that works. These triangles are similar. If we could say these sides are parallel, that's maybe more obvious. 10 divided by 6 is the same as 20 divided by 12. So that works. Now it worked well for us in this situation. How would we do it in a more general situation? So what we would need to do is say that this is x, say, and then we'd say x divided by 6 would be equal to x plus 10 divided by 12. And then we need to solve this equation. It's not an easy equation to solve. 12x is 6x plus 10. Of course, if we've got the calculator, which we would have for this question, we could just solve on the calculator. So 12x is 6x plus 60, and then 6x equals 60, so x is 10. So we could get it just by reasoning it before, but we can show that we can also calculate it. So now, to get at this curved surface here that we actually want, what we're going to do is work out the curved surface of the entire cone and then take away the curved surface of the top bit. So for the big cone, the slant height is 20, and for the small cone the slant height is 10, and the radius for the small one is 3. No, that's the diameter, that's 6. And for the big cone, r is equal to 6, half of the 12. So the surface area that we need to paint is made up of the small circle at the top with a radius of 3, so that's pi multiplied by 3 squared, and also pi times 6 squared for the circle at the bottom. And then we've got the curved surface, which is going to be pi times r times l for the whole cone, take away pi times 3 times 10 for the small one. And once we've got those written down nice and clearly, each part, it's best to calculate all in one go. So we have pi multiplied by 3 squared added to pi multiplied by 6 squared, and then add, use a bracket, pi times 6 times 20, take away pi times 3 times 10, and that gives me 424.115 and so on. So let's say that's 424, and the units of length were centimeters, so the area would be centimeters squared to the nearest centimeters squared.